Oh, I'm not talking about that.
Okay, go ahead and write down this on your board. Don't do it too big. What was that? What I want you to write down is just the x is greater than -2 and x is less than 5, and this, the in-between statement. And I want you to have that written down as an example, and then when I show you a few others that you're going to try on your own, you have an example there for you to look at. So I want you to notice how the left one flips around. We have x is x is greater than -2 right here, but then down here it's this, but just flipped around. So remember, all the numbers greater than or bigger than -2 is the same thing as -2 is less than all these numbers. These two are logically the same. They mean the same thing. All right, got that down? All right. So let's look at this. How we write number 1 as an in-between statement? You have one on your board already. Use an example. Okay. So what will we do here? Again, the small number is always on the left, so that's how you know which one to flip around. It doesn't actually have to be the first one. It can be any one, but everyone's smaller. So here, I'm going to flip around this one because -3 is less than 5. Okay. So it's -3 less than x instead of x greater than -3. And then I just drop down the bigger one. X is less than 5. X is less than 5. It all comes together.
Is it always going to be like the signs are always going one right there from my way, or whatever makes it?
Well, the signs are always going to be less than or equal to.
I mean, like, will it ever look like this?
No. You have to. Both arrows will always point to the left no matter what. Yeah. Okay. Try number 2. And the proper way of saying this is simply -3 is less than x is less than 5. So you have to say is less than 2 times. So let's read from left to right. So number 2, what do we got? How would you say that out loud? The answer out loud. Yeah?
Alright, number 2. 4 is less than x. X is less than 10.
4 is less than x is less than 10. Yeah. Perfect. And 3. Write it down, please, so I can see it on the board. And yeah, if you want to grab it, you're graphing it, that's fine. Alright. Last one, number 3. -8 is less than x, less than -1. So in each one of these, each one of these, the smaller one is the one that's flipped around, okay? And the bigger one just kind of drops down. You can see this right here, the x less than 10 right here, you can see x less than -1 right here at the end. That's always the case. So more than anything else, when we actually get to solving these, it's going to be exactly the same thing we've always been doing. Okay, you divide by both sides, you change the sign, you divide by negative, you add, subtract first, then multiply, divide. That hasn't changed. It's just how you write your answers. That's new here. Okay. So here, go ahead and watch here. This is what you're going to be solving. Now, this is really two different inequalities. There's the left inequality, okay, and the right inequality. So if I look at just this, drop the less than 7, I'll get this. If I drop the -4 less than, I'll get this. You notice how the middle is in both of them. So what you can do is go through and solve each one of these one by one. Right? I want all the numbers bigger than -7 and less than 4. Right? That's the same as all the numbers between -7 and 4. So what we just practiced is that one last step. After you finish solving, you do one last step. When you have and, only when you have and write it like that. However, I'm going to have you guys do it a slightly different way in your work. Try this. Try subtracting 3 from the left, middle, and right. This is weird because usually we subtract 3 from both sides. But we have 3 different parts. We have a left and a right. Like, oh, it's the left and the middle. And this is going to do the exact same thing. Look at the two answers. And see the right-hand side, how much faster it is in getting the answer. So anytime you have a method that works faster, and it always works, you get the same result, let's use that method. So the right side works, the left side is why it works. Alright, of course, when you graph it, notice that I'm not spending all this time, if I'm doing it myself, putting all the different numbers in between. I'm just using the numbers that I need. And we can jump it up to a two-step. Go ahead and erase and write that down. Let's do this one together. Anybody guess what the first step's going to be? Yeah, subtract 4. So you kind of already see that, well, it's the same steps. It looks a little different. I'm starting by the variable. I see 3x plus 4. The first thing you do is do the adding, subtracting. Since this is a plus 4, go ahead and subtract 4 from the left, middle, and right. And draw a nice horizontal line. And go ahead and do subtracting 4 3 times. What do you get on the left? -9. What do you get in the middle? Yeah, 0, and 3x plus 0 is 3x. And what do you get on the right? 3. And then bring down the inequality signs, both of them. Okay. What do you suppose comes next? Divide by 3. Yeah. So divide everything by 3. Good. And what do you get on the left? You get -3 on the left. -9 divided by 3 is -3. The middle is just 1x. 3 divided by 3 is 1. So we get x. And the right side, 3 divided by 3 is 1. Now, how many open, how many close?
One.
Alright, so the left one is open or close?
Open.
And the right is closed. Alright. So draw your graph just like that. Don't. Draw your graph. There's one open, one closed, and what should all of these look like? If they have the word "and," what should the graphs look like? Are they between or going away? Between is the word you want to use. So all the numbers between -3 and 1, including 1, should look like this. -3, open, 1, close, and this means all the numbers in between, so they're connected. The biggest thing is that we're going to combine the ors and the ands. And you're going to have to know, well, this one's an or, so they go away, this one's an and, so they're connected, and so on.
So it's not going to be like the numbers up to infinity.
Right. Not going to be like that. Okay. I'll just show you this one, and then we'll get started. That if you subtract 6 on both sides, we'll get this. But watch this. When you divide by a negative, all the signs end up switching. So you can see this is not in the correct format. What is wrong about this? There's two things wrong. Number one, is the number on the left the smallest number? No, so that's wrong. And are the signs less than? Or less than or equal to? No. So just like before, we have to flip that whole thing around. To flip the whole thing around. So when you end up dividing by a negative and it's in the middle, just know your final answer. The whole thing might be you might have to flip it all around. So that in your final answer, the number on the left is always the smallest, and the two inequality signs are always pointing to the left. That's going to be true for all of them. Okay? And you want to look at this two ways. -2 is less than x is less than or equal to 10. Or you can just say all the numbers between -2 and 10, including 10. So it's called an in-between statement, so you can say it that way as well. What's the answer if all the numbers between -2 and 10? So that's what your graph will look like. You'll highlight all the numbers, or you draw a line for all the numbers that are between those two. Okay, that's going to be it. Let's pass out. Okay, so just to start off, we have just two separate inequalities that are separated by the word and. So this is the first kind where it's not that one big in-between statement with two inequalities, but just two separate things like we've been doing all along. So from here, you pretty much know what to do. And you do the same thing we have to do. Side of the variable, do the opposite, -9, opposite is positive 9. That adds to 0. X greater than or equal to, what's -17 plus 9? -8. And then we got what divided by 3 is 1. So we have to know when we look at this fraction, that's division. So the way to undo division, multiply both sides. 3 divided by 3 is 1. And 1 times 3 is 3. So this answer is all the numbers bigger than -8, but less than 3. Okay? Rewrite this as an in-between statement. So take the first one, flip it around. -8 is less than equal to x. And then take the second one with a bigger number and just bring it together. So less than. So my final answer is all the numbers between -8 and 3, including -8. Go over here. equals -8, and open on 3, and then everything in between. Again, because it's the word and, that's how I know it's going to be between. It's going to be that on all of these problems, but tomorrow when you start reviewing and plus the ors, it's going to be both. Some are going to be between these, some are going to be away. Question?
When you do this step of subtract on the side, have you
Well, it's always start beside the variable. So always the same steps we've done before. Where the variable is, do the opposite of everything. -9 add 9, 5 by 3 multiplied by 3. That has not changed. That's the same thing we've already had done. Alright, so here, let's go down to 3. Here is where you'll see it changing a little bit. Now we have a left, a middle, and a right. So start wherever the variable is. So that has not changed. So the variable is b plus 6. So we have a plus 6. What's the opposite of plus 6?
Subtract 6.
And then we do it from the middle, the left, and the right. So 3 times. That's new. 11 minus 6 is 5. And 6 minus 6, 0. So we get B. And then 7 minus 6, we get 1. Now, is this correct format?
No.
No. Small numbers on the right, these are greater than, so flip the whole thing over. So we get 1 is less than, B is less than.
Oh, shoot.